Everyone loves a fun lathe project. So I bought this lathe about 5 years ago. It's a 1941 Monarch CK12. And a little bit of maintenance I've had to do in the headstock area, but otherwise it's been working pretty good. One thing that was actually missing when I bought it is there's a couple screws that go right there that when you put the chuck in, prevent it from rotating. So you got this Morse taper on there, you slide it in, and this spins, which is fine if you have something like a live center where you want to support parts. But usually when you're putting a chuck in, you want to drill, so you want it to stop. Well, you can kind of see in here, it can just rotate freely. Now there's supposed to be some little screws in there. Well, those are missing. And of course, I measured them with a caliper, pulled up the Handy Machinery's handbook, and oh hey look, it's about the right size thread for something that's a standard UNF thread. Cool, I'll just go on McMaster or go to the hardware store and buy it. No. Of course, 1941, they did goofy stuff, and it's an 11/16-16, so 11/16 diameter, 16 thread per inch, and you can't buy it. Well, when you own a lathe and you need to make parts for your lathe, you can use your lathe. So got a fun single point turning project here, and then we can get back to hogging with the tailstock and really making this 3 horsepower VFD really make some chips. So let's get started with the math. So before you can get to the fun math and design part, make sure you have your friendly little math wiener, aka your math dachshund. Ember, do you want to help me do some math? Of course you do. Grab your machiner's handbook and a piece of paper. Okay, and next step for making these parts here is the drawing, design, and math parts. So what I knew I needed when I measured is I had about a 630 thou diameter hole for the thread, and that's the minor diameter of the thread in the actual hole on the tailstock. So I knew about 622, it's some type of thread. Okay, so I pulled up the good old Machinery's handbook, and this is the 25th edition, but pretty much the same from like the 1940s and even 30s all the way up to today. This is a gift from my master toolmaker I used to work under when I did basically my machining apprentice. So got this as kind of a graduation gift from him. I'm gonna open up the page here to the unified screw threads, and I saved you the fun of flipping through all the pages. But basically what I knew is I needed about a 630 thou diameter minor thread for an internal. So I went, okay, that's your internal, and went down to find about 6 minor diameter, about 630. And I was like, ooh, 630, yeah, that's close, 633, 644. I could see that, and I went over. If it focuses, there we go. I had about 630, so I went 62 or 620 to 634. I had measured 631, so I'll go over here. 11/16-16. Like I mentioned, I went to McMaster, and you can't buy that bolt. You can buy different up and down. 11/16-18 was one of them I found, which oddly enough isn't in here. But, okay. Anyways, so I knew what now my internal thread diameter, it's 11/16, probably 16. Went out, checked, yep, it's 16 thread per inch, so I need to make a male or an external thread. So I need to be major diameter here, 686 to 687.5. Average there is 681. I need to have 622 diameter shank at the bottom, about 200 thou thread, 1 inch long, and turn that on the lathe. So now we're gonna go have some fun actually cutting some parts.
Comes up with an idea, and then somebody else sees it, tweaks it, changes it, and then turns it into a big business. There are dozens of promoters that lead these events across the country, dozens. But Joe Connolly stands.
Okay, so we got the part. You can see it's got the thread and the shank part. Let's see if it fits. Okay, it does. Locks in. Looks like it might be a little bit long, because I want the thread to bottom out at the top. Focus. There we go. So I want the thread to bottom out, and it looks a little bit long. So if I machine a little bit off the edge, and then maybe take a little bit off the top, maybe chamfer it, I think it'll work. Fancy. Now we got our little part. Parted it off, cut its length. Looks like it threads okay. Now I just need to cut a slot in the top for a flathead or something. If I was fancy, I would rotary broach a hex into it. However, I don't have the $800 rotary broach, and I'm just gonna use our friend the Portaband bandsaw to do this one. Okay, well, let's see how it works. Looks like it's in there. And it tracks without binding. Pop it out. And it looks like it's restricting moment, so cool. One down, one to go.